So as I talked about in part one, is that even if we're looking at angle of depression or angle of elevation to begin with, we know that if we look at the alternate interior angle, it's going to be the same angle measurement. So if we look at a right triangle, this is how that angle of depression or angle of elevation is going to look. So due to the fact that both angle of depression and angle of elevation are between the two parallel lines, and our transversal is going to be that hypotenuse across from the 90 degrees, that our angle of depression and angle of elevation are going to be congruent to each other. Very, very important as we go into some of these word problems. So let's look at an example. At a certain time of day, the angle of elevation of the sun is 44 degrees. Find the length of the shadow cast by a building 30 meters high. So if you are really good at drawing, this is your time to shine. Mine are not going to be perfect, so please bear with me. From the ground, I have a building that is 30, I think it is meters high. So either side is going to be 30 meters. The sun is going to be on one side. You can create a little circle, and it's going to cast its rays against this building. And then the shadow of the building is going to go to the other side. And then the sunshine is going to have a 44 degree elevation. So this is what we were given. We were told that the sun is going to give a 44 degree elevation rays towards the building, and then the building is going to cast a shadow on the other side. So we have to assume that these two triangles are congruent. So if this side is 30 meters, this side is 30 meters. If this angle of elevation is 44 degrees, this angle over here is going to be 44 degrees. Another thing that we can assume is that with the ground and the building, it is going to create a 90 degree angle. And then we are asked, how long is the shadow on the ground on the other side of the building? So we want to find out this length here. So the triangle we're truly looking at is a 90 degree triangle, or right triangle. X as the bottom leg, 30 as the left leg, and 40 degrees given for one of the angles. And then we go into, what do we know? What do we need to find out? Which trig function are we going to use? And then solving it. So we have our angle, so we know our angle. We also know the opposite side of the triangle. Also know opposite side. So what we need to find out is the side adjacent to the angle that's given. It is not the hypotenuse, because the hypotenuse would be across from the 90 degree angle, and we don't need that in this problem. So we need to find the adjacent side. Now, with knowing our angle, knowing our opposite side, and also involving our adjacent side, we have to figure out which trig function we're going to use. So how we determine our trig function that we're going to use is using SOHCAHTOA. Which one involves an O and an A? Well, here's an O, here's an A together. So we're going to be using our T, which is for tangent. And then we set it up. So our tangent function is tan of the angle equals our opposite side over our adjacent side. And in this case, we have an angle measurement of 44 degrees. Our opposite side is 30, and our adjacent side is x. So that is the function or equation we're going to be using to solve this problem. Now to solve for x, you can do one of two things. I'm going to show you the long way just in case you don't understand the short way. And it is okay if you only can do the long way. First thing you want to do is get rid of the fraction. So you want to multiply by x, multiply by x. And you get x times tangent of 44 degrees equals, well, the x's cancel out. Division of x multiplied by x cancels out, and you get 30. And then you will need to divide by tangent of 44 to get x by itself, to get rid of the multiplication of that tangent. So tangent of 44 over tangent of 44 cancels out, and you're left with x equals 30 over tan of 44. Now, if you go back to week 2, I did an extra video just showing you how to put this into the calculator. If you did not understand it, please go rewatch it, or email me and I can send you another video. If you are not liking the online version of the graphing calculator, you can do this in Desmos. I will also create a video if needed, how to use Desmos for these problems. But either way, once you put it into your calculator, your x should come out approximately 31.0659, so on and so forth. So I would, for your solution, simply put 31, and we're looking for a side, and the other side was in meters, so we can assume this is in meters as well. So that would be your answer for number 1. Number 2 is a little bit simpler. So you have a 20-foot ladder leans against a wall so that the base of the ladder is 8 feet from the base of the building. What is the ladder's angle of elevation? So you're going to draw the ground. You're going to have a building coming out of the ground, and this always will create a 90-degree angle with the ground. And then you have a ladder that is leaning against the building. And again, this does not have to be perfect. The ladder is 20, I believe it's feet. And then the base of the ladder is 8 feet from the base of the building. So that means from the bottom of the ladder and the bottom of the building, we have 8 feet. And the question is the angle of elevation. So from the ground, or that bottom parallel line, to the transversal, or to the thing leaning, what is this angle? So you can put a question mark, you can put a variable, or you can put the typical variable for angle measurement, which is theta. Doesn't matter which one you use. So on my answer key, I used X. I'm going to use X on this one. So what do we know? We know and I'm going to do it in red again. So we know the hypotenuse. We also know the adjacent side of the angle that's involved. So we also know the adjacent side. So what do we need to know? What do we need to find out? Well, we need to find out the angle. So which trig function are we going to be using? Well, if you need to write it out every single time, write out your SOHCAHTOA. Which one involves an H and an A? Well, A and H are together right there. So our trig function is going to be C for cosine. So we have cosine, that's not what I wanted. So we're going to have cosine of X equals adjacent over hypotenuse, which in this case we have cosine of the angle X equals our adjacent side is 8 over our hypotenuse, which is 20. And we need to solve for this. Solve for X in this. So to get X by itself, we do not just divide by cosine. There isn't multiplication in between cosine and X. To get rid of it, we have to take the inverse of cosine. So we're going to say, all right, inverse cosine on one side, and what we do on one side, we have to do to the other. So on the right side, we end up with X equals, and the right side, we have inverse cosine of 8 over 20. Again, in the extra video I did for week 2, I show you how to put this in the calculator. Once you put this into the calculator, you get approximately X equals 66.42. So the equation we used was in that red, last thing in red, cosine X equals 8 over 20. And your answer would be approximately 66.4 degrees. If you do not remember from that extra video, we are always talking about degrees so far. We will not be talking about radians or any other kind of degree, any other kind of angles in this semester. Okay, let's try one more. So example 3 says at a point on the ground 50 feet from the top of a tree, the angle of elevation to the top of the tree is 53 degrees. Find the height of the tree. So let's create some grass. We're going to create a tree. There's some leaves on the tree. Again, it doesn't have to be perfect. We're going to assume this tree does create a 90-degree angle with the ground. And from the top of the tree to a point on the ground, so it doesn't have to be a specific point on the ground. And at the point of the ground, 50 feet from the foot of the tree. So that 50 feet from the foot of the tree will be on this leg, this bottom leg. The angle of elevation to the top of the tree, so the elevation from the bottom parallel line is 53 degrees. And we're wanting to know the height of the tree. So you can put any variable you want. I always go with x because it's universal. So if you want to redraw the triangle, you always can once you have an idea of what's going on. And we have to go through those steps again. What do we know? What do we need to know? And which trig function are we going to use? So we know the angle, and we know the adjacent side. We need to know the opposite side of the angle given. So which trig function do we need to use? So we have A and O involved. Which one has O and A involved in the trig function? Well, O and A is there together, so we're using tangent. So tan of the angle given, or the angle involved, equals O first, so opposite side first, over adjacent side, which is 50. So this is the equation that we're going to be using. To get x by itself, we have to get rid of the denominator. So we're going to multiply by 50 on both sides. On the left side, we have 50 times tangent of 53 equals division of 50 and multiplication of 50 cancels out, and we're left with x. Once you put this into the calculator, you get approximately x equals 66.35, and that would be your solution. Okay. Going on to the next page, if you're following along, I want you to pause the video and attempt example 4 and example 5. So for example 4, you should have gotten 59 degrees, approximately 59 degrees. For example 5, you should have gotten approximately 412.2, and I believe that is in feet. Now let's go over example 6 together. So example 6 is a little bit more complicated. A person at one end of a 230-foot bridge. So I've already put both sides of our bridge, created our bridge, and created a person. So across a 230-foot bridge. So the brown is 230. The person spots the river's edge directly below the opposite end of the bridge. So we're talking from the person, across the bridge and down. Finds that the angle of depression, so from the top line to the transversal, which is 57 degrees. How far below the bridge is the river? And what we're having to find out is from the one side to the bottom, what is this length? So there are two ways to look at this. If this red side is x length, that means the other side is x length. Another thing that you can realize is that if our bridge goes across this little valley of 230 feet or meters or whatever it was, that means the bottom the length of the river in between the two sides is also 230. Now, from the top parallel line to the bottom parallel line, we have that yellow line that is cutting through it, kind of like our transversal that we talked about at the beginning of this video. So if our angle of depression is 57 degrees, that means our angle of elevation is also 57 degrees. So whichever one you see easiest, you can look at the right triangle that is right here. That is the 230 at the bottom, 57 degrees as the elevation, and X as the other leg. Or the upside down triangle, that has 230 as the top leg, X as the leg off to the right, and the angle of depression of 57 degrees. Doesn't matter which one, whichever one you choose, you're using, or you know, the same kind of information. So in each of these, you know the adjacent side from the angle given. So you know the angle and the adjacent side. We need to know, or need to find out, the opposite side of the given angle. What's burning?
That was just crumbs from the toaster.
Okay. Once we know our known information and our information that we need to find out, we can find out what our trig function is going to be. So we have SOHCAHTOA, we have an O and an A involved. So the only trig function involving an O and an A is our T, which is our tangent. So we have tan of our angle given equals opposite, which is X, over our adjacent, which is 230. That is going to be our equation that we use. And equals X over 230. We're going to get X by itself. So to get rid of the division of 230, we're going to multiply by 230 on both sides. We have 230 times tangent of 57 equals X. Then we're going to put this into our calculator, and we get X is approximately 354.1689, which I would round that to 354.2. So that is our example 6. So if you have any additional questions, please do not hesitate to contact me. And I hope you have a good day.